Cool. So I believe that is now recording. Thanks everyone for being game to try this. If it works well for us, then we can continue doing this in the future instead of Google Hangouts. And hopefully it'll be a bit more stable. Right now, this is running off of, I have an account with LBL. And so that lets me record, but I think that what I can do is for meetings where I'm not here, I believe that I can assign other people and let you also like take control of the meeting and be able to record stuff and things like that.
Yeah,
recording, it then saves to your computer and then we'd have to upload it to YouTube. So it's like one more step than before, but hopefully not everybody randomly gets kicked out because that would be unfortunate. So with that, let's maybe go for quick reports. And it looks like Seogi has something. So I don't know if you would like to start us off.
Not sure. I'm not sure who asked last meeting. It was either Dom or Sarah. She was working on some inversion of like DC inversion, but there was like a very sharp boundary. So yeah, I think I was working on similar problem. So I wanted to kind of just share what's the possibility. Let me see if I can share my screen. Can you see that?
Yes.
Okay. Is that large enough, or is that better?
You have a weird black band.
Yeah, I got the same thing.
Is that working? No?
Well, there was a black band that was dancing around.
Black.
You only see the bottom 3/4. Don't show anything on top.
oh, I see. Let me stop sharing.
I think the black band was where we're seeing all of the images from the people. Oh, there we go.
That's better.
Is that better?
Oh, it's better.
Okay. Okay. Well, seems like working. So here's an idea. Like this is a model. So I was working on like a seawater intrusion problem here, and the problem is like you got an interface between fresh water here and the seawater. So that's like what your main interest. But you have other structures on top of that. So how do we invert like both interface and the structures, like isolated like structures? So like a usual way we do a voxel inversion, and that's like I'm running 2D inversion, and that's what you would get. We're still fitting the data pretty well, but yeah, you can see like a large scale structure, but you're kind of losing where the interface is.
That's a uniform reference model, Sug?
Yes. So I think so I'm like I'm just basically using smoothness. So alpha S is really small.
Yeah, but your reference model is?
It's just a homogeneous half space, 20 ohm meter, for instance.
Okay, yeah, right on.
Okay, but like yeah, impact of reference model is pretty small here. Okay, so I'm fitting the data. That's what I'm getting, and then like now what I'm doing is I could just do a parametric inversion. Okay, so but what's going to happen is I'm going to find like an interface and the two values, but like I'm finding in a wrong place because like that's not enough. Your model is more complicated. And then what we could do, we can combine that. So let's say we want to invert for both interface and the two values, plus some structures. So here's how I'm building things up. So I haven't done anything. I just like put things together. So Dom built this submap. And then I build at one point, where is the like a polynomial map. So this is the parameter of polynomial function. So you got two values and some geometry about the interface. And I'm using the wires to kind of like connect them. Okay, so you run the inversion and that's what you would get. So we find the interface and the two values plus the structures. So like yeah, that's a kind of example. And I think that the Sarah's problem might be pretty similar to this. The context is a bit different. So yeah, it's ready. I can share this notebook to her. And if she's interested, she could try this.
That's great, man. How would you deal with like a non-straight surface? Like just use like a higher order polynomial or something?
Yeah. You can use like a higher order polynomial. So yeah. So I think I'm not sure which order that I used, but yeah. So if you like, I think I was using like a second or third, but you can increase that.
Because I remember you inverted once nodes for the location of the nodes of a surface or an arbitrary triangulated surface.
Right. So I could do. So this is another example.
All right.
Rather than like using polynomial, I can think about, okay, so each point of the cells here has a z value. So let's say I got an interface here, okay? And then let's say I got like 10 cells in x direction. So each x cells have a z value, a depth value. Right, I can invert for that value and then put a smooth constraint, for instance, to make an interface. Is that kind of clear?
That's exactly what I thought. Yeah, it's good, man.
Okay, perfect. So yeah, so this is an example, a little bit different example. So here I was interested in the water table. Let's say this is the dry part and that's a saturated part. And then in both regions, you got some like a sand background and a clay lens. Okay. Then what I'm doing, so I'm just going to go ahead and do the same thing. So I'm going to do an L2 inversion. So this is actually 1D inversion, like using constraint, okay? It's not a 2D, actual 2D example. But anyway, what you're getting is like kind of something like that. So you would see some sort of interface, but that's not quite right. Okay. And then what we could do now, we are doing the similar things. Like, okay, I'm gonna break that apart to two, like a region, and then invert for interface and the values, plus structures. That's what you get here. So it doesn't look great because like there's a variability. So it's a non-unique problem. And yeah, this example is not great, but actually I had a better example. Like so that's an idea. But if I'm using the polynomial and then a little bit like all your time channels, that's what I would get. So yeah, it's yeah, like you need some sort of fine tuning. Like yeah, that's.
You would rather move the connectivity, or I guess the resistivity, than add a conductor.
Can you repeat?
Yeah, like it instead of putting two instead of putting two conductors, it pushed the resistivity in between the blocks, right? Go back to where you were. Go back to your first one.
Just give me a sec.
All right, so instead of putting, is that resistivity or connectivity? I'm not sure.
It's a resistivity.
Yeah. So instead of putting two conductors, it preferred pushing the resistivity in between the two blocks. That's interesting.
Right. So yeah. So there's a whole bunch of models that could fit the data. That's what we're up against. Yeah. So like kind of it depends. So if the real goal was actually finding a water table, I think I would get rid of some late time channels, which is really kind of contaminated by this like sand channels, I think. So yeah, you need a little bit of fine tuning.
I got a question, Seogi.
Mm-hmm.
So I guess, is there a possibility you could invert data that are sensitive to this big interface and do a parametric inversion, or maybe you do a voxel inversion, and just recover this large-scale geological feature correctly, and use that as a starting and reference model on a voxel inversion to then try and recover.
Yeah, so that's exactly what Mike McMillan did, right? So that's what he's called hybrid inversion. One of my colleagues here, Meredith, she actually tried that for a seawater intrusion problem. So she used like some DC data at a lab scale, and then she tried the same thing. Like use that. Like I think there's a little bit of like a trick because like your data actually includes everything. It's not really including just the parametric surface. So it's somehow like if you want to get a large scale like a model, then kind of like a ballpark model, you would set the high uncertainty when you're sort of like doing a first order like parametric inversion.
Yeah.
You may set kind of like your order of polynomial pretty low because you don't want to put a lot of structures on your interface. So then once you got that, and then you can use that as a reference model later to kind of like for your voxel inversion. So I mean, that's another possibility.
That's kind of better, right? Because you're doing both at the same time. So we could do a joint inversion, but the only point of connection is that parametric model of 1 and 2. And then you can let them both do like full heterogeneity in their own physical properties. You know what I mean? So let's say density and susceptibility could both try to agree on the interface for the basement, and then you let them do whatever they want for the rest. But they're joint. Yeah. Yeah.
Like an actual little bit of detail is because if you think about here we need to be a little bit careful because we're thinking like our property is a log resistivity or log conductivity. So if like you need to think about when do you want to sum, right? Because if you're summing that up in a log space, you're actually multiplying it. So that's probably what you may not want to do. So you may want to move everything into a resistivity or conductivity space, then sum that up, right? So there are actually like bit of details to make things work. And there's a little bit of like a kind of disadvantage here. So I can always put the, I think it's one way. So I can always put the conductor, I think in this case, for the voxel part. I can't really put the resistor. So yeah, if you actually write down and then you can figure it out, but that's a bit of a like disadvantage for this methodology. Yeah, so that's what's that.
That'll be super useful, man. We'll be using it next month for sure.
No problem.
You gonna put it on Slack?
Yeah, I'll put it on Slack.
Perfect.
Okay, now you mentioned it's a bit more familiar. You're like summing a like large scale background model plus like a sort of perturbation to get finer structures.
So you don't need to worry about segmenting your data, right? You just throw everything at it.
Yeah, that makes sense. That's cool.
But you're updating your reference model for the small perturbation.
There's no reference. You just don't put any reference. Just smoothing or whatever structure.
Yeah. Okay. Yeah.
Yeah, and next week I might have a little. I think so. I was using LP inversion quite a bit, in the context of like hydrogeological problems. I can kind of update that part later next week. So like the problem that I have here, we got a lot of well data as well. So, I mean, but the situation here, people don't really use the well data. But what's actually happening, so in a consulting company, so they really try to fit the data well. And then like I try a bunch of them and then find the model that kind of like matches well with the well data that they have. So that's sort of the current framework, which is not bad, right? You're still doing some inversion, find the best match. So we're going to get an optimal model. So that's sort of the workflow here. But then on my end, why don't you put that in to your inversion? I mean, even like with the conventional methodology, you can put quite a bit of information into your inversion, like a reference model or bones. But that's not really happening because like it just looked like a little bit cumbersome in a commercial package, or it's actually impossible to put that in to your commercial package. So yeah, that's sort of what I'm working on. And then maybe in that space, we can use LP norm. So like we integrate everything into an inversion. Got a lot of prior knowledge about that. And then use whatever functionality that we have in inversion to estimate some sort of uncertainty. So I mean, like here, we're getting more samples to estimate some uncertainty in your model space. So I mean, that's sort of what I'm working on, and yeah, I kind of want to show later.
Awesome, thanks, Seogi. Any other questions? No. Does anybody else have quick updates that you'd like to share?
Yeah, I think maybe just my weekly prod, getting tutorials merged in so that I can move on to new stuff.
Did you take a look, Devin? I left some comments there. This is discretized right now?
Discretize, and I'd also like to move on the stuff I did for SimPEG, because there's a good preliminary refactor of the website, and there's also tutorials on models and mapping, which...
Okay, but did you take a look? I left some comments, and I didn't see necessarily on the discretized one, if you had a chance to address the handful of lingering comments. So there's some conversations that are not yet resolved.
Yeah.
So I left a comment just saying, can you ping when those are done? And so, yeah, so if you don't mind taking a look at that, and then just feel free to ping once you're happy with, and those little comments, the lingering ones, are resolved.
All right, yeah, I'll just do it this afternoon. I thought I went through everything after the last meeting, but maybe there's something since then, so I'll take a look.
Excellent, thanks, Dev. Cool. Anybody else? No? Okay, then let's maybe move on to the simulation refactor, if folks are good with that. So just a quick status update as to where we're at with progressing through SimPEG. Basically, as of this morning, the whole electromagnetics stack of SimPEG is on the simulation. I haven't necessarily pushed it, so that right now the spectral induced polarization is the last one that I did. But right now, if you go and if you look at frequency domain, time domain, natural source EM, DC, or induced polarization, all of those should now be sitting on the simulation class. I'll make sure that SIP is up after the meeting. And so what I wanted to do is I've got a notebook just running through an EM inversion, and we can use this as a way to just chat about some of the changes, and then yeah, work on any sort of clarifications, and go from there. So I'm just going to share my screen. Let's see if that works. Can you see that?
Yeah.
Okay. Okay. So one of the first things I tried to do, at least internally within SimPEG, is now always import discretize instead of importing mesh. Down the line, I think this is easier to debug because it's just exactly the true thing that we're calling. That said, if you want to do from SimPEG import mesh, that will still work. And then the other thing to note is now renaming things, trying to be a little more in line with Python standards. So all of the module names are lowercase. And if they're two words, we use an underscore. So data misfit is now just data underscore misfit. Inverse problem is inverse underscore problem. Then here, if you look at module names for the physics, now instead of using shorthand and all caps, spelling it out. So in this case, what I've done is we're from SimPEG electromagnetics, import frequency domain as FDEM. So I would do the same thing for importing DC, for example. Right now, it's under So throughout all the testing right now, and eventually in the examples, this is I think a pattern that is kind of nice to follow, is that we spell it out full force in the package. But then when we're importing stuff into examples or into your own code, I think using shorthand is totally fine. If you want to stick with spelling it out in your own code, that's also fine. But I think there's sort of enough of a standard, and this keeps it a little more concise. So it should be fairly straightforward to go in and change those things. One thing that I will do with this is also allow from simpeg.old API import star. And this will import the old namespace, but sitting on sort of the new framework. So all of the changes that I discuss as is following, like if you were to import problem here, if you spell that properly, it would still be importing the simulation class, but as problem. So it's still going to be behaving like the simulation class. So everything is sort of moving on to this. The only reason this exists is to help ease the transition with namespace and things like that. So I'll walk through this example and highlight where things are changing, and then we can go in and look at code as is helpful. So names, we're just going to create a mesh like usual. One of the reasons I like using discretize now at top level for creating meshes is because I like calling my mesh mesh. And if you import that from SimPEG as mesh, it's now you're overloading names and it's confusing. So this is a pattern I would try and encourage folks to follow. So we make a sil mesh, nothing here has changed, that's all discretized, that's great. I'm gonna make a 1D model because we're gonna do a 1D inversion. So this is all just NumPy basically, right? I'm just arranging a vector, so nothing special here. When we look at the maps, now maps is lowercase, that's the only thing that's changed there. So I can go ahead and plot my model. That's great. We've got a conductive layer and a resistive half space. So that's what we're going to work with. So nothing there has really changed other than uppercase maps went to lowercase maps. Okay, so this is now where things start to change just a little bit. So here we're now working with FDEM. We're going to set up a survey. So I've got sources and receivers. So right now, I've actually spelled out receivers, so you can see that, and I've also spelled out sources. To ease the transition, this still exists. But right now, so like we previously used to call source SRC, and that's how you found your sources. So that still exists in the namespace, but eventually we'll depreciate that. So try and move things over to here, but didn't want it to be too painful of a change. Here, so this is similar to what we had before. One thing that changed is, so before we used to always do rx, so let's do re.locks. Right now that's going to throw a warning. And so instead we're going to try and use locations. It'll still let you set lokes, and same thing on the source, it'll still let you set loc, but it's going to throw this warning every time and say, please use locations or location. So just trying to spell things out and use a little bit less shorthand. These are the same as before, component orientation. One thing that's kind of nice is with properties, it lets you cast things. So for example, if instead of spelling out real, I used RE, that's fine. It'll accept that and it'll cast it to real under the hood. So that's kind of nice, is that, you know, for different people, if you're using different shorthand, or instead of using imag, I actually spelled out imaginary, it'll just all cast it to the same thing. If you want to see that, I can show you the code afterwards, but that's just like a minor convenience thing. Same as before, we have an orientation. Then here, when we construct a source list, so we've got FDEM sources, meg dipole, so that API is the same. Instead of using freq, F-R-E-Q, we're using frequency. Same thing again, it'll still let you set using F-R-E-Q, but it'll throw a warning.
So properties are in camel still? Is that the idea? Kind of a mix?
Properties, no. So properties, ideally, we use always lowercase. What are you picking up on, Dom?
Well, because for receivers you have point_B and it's an uppercase, and then mag dipole is the camel style. So
yeah, okay. So classes should be uppercase and camel style. So mag dipole is a class, so that's okay. This I don't actually like. I agree we should be consistent and not use, so for classes you don't typically use underscores. For the initial refactor, I was sort of going to let this level of stuff continue, and then we can hit it in another refactor, or like hit it in the next iteration. But ideally, and this is a question and something I would like to talk with folks about afterwards, is I actually think that we should potentially just get rid of like this trailing part and just have point receivers, dipole receivers, and then we tell it which field to sample. Because right now, like the difference between these is really trivial in the way that the class is constructed. So I think it's a little silly to have them as separate classes, but I think that's a conversation we can table for now and think about it later. But yeah, agreed. This is sort of non-Pythonic naming convention. Okay, so there's a few things that have changed with the survey. So you still instantiate the survey the same way. It has a source list. It takes a source list, and the source list has, each source has a receiver list. But the survey now no longer has the dpred method. It also, there's no longer any pairing that you do between the problem or the simulation now and the survey. So when we instantiate a simulation, and right now this is a bit confusing and I think probably worth changing before we move this in. The use of the term problem here is simply just because like I wanted the API, at least for now, to be the same, but we can perhaps call this simulation 3D B field or something like that. B. But that's okay. We'll ignore that detail for now. But you can see here, so one important thing that's changed is now the simulation takes a survey when you instantiate it. You can still, so if we had not passed this, it will still let you do this. But if I did not have warnings suppressed, all this does, actually, let me show, I'm just going to stop sharing for a second and reshare my entire screen. So here, if we actually look in the code at what that does, so if we look at the base simulation, if you actually call pair, this is what's happened. Is all it's doing is saying, don't do that, but okay, I'll let you. And then it just sets the survey. So it says self.survey is survey. So that's all that that's doing. So it's not necessary anymore in your code, but if that's the way that you're used to having like set up a simulation-like object, it's still gonna let you do that. One of the nice byproducts of this or side effects of this is that you can actually reuse the same survey in different simulations, and you don't have to deal with the pair-unpair craziness. Okay, so we've constructed our survey and our simulation object. There's a few warnings that are popping up because I haven't gone through the code rigorously and gotten rid of all of the old style naming. So like, for example, here, trying to use source list instead of src list. It's still gonna let me use it, but it's gonna throw warnings. So now I wanna show you, there's a few different things going on. So if we actually look at the simulation, it now has the dpred method. It also has fields like it used to before. And it also has a make synthetic data method. So previously the survey had the ability to make synthetic data. That's no longer true. The survey is a very lightweight object. All it does is store sources and receivers and for example, in the frequency domain, it knows how many unique frequencies it has in it, and it knows how many data it has in it. But other than that, like, it can't really do anything useful for you in terms of like computing things. It stores the survey. It also does not have any data attached to it anymore. When you used to create or run survey.make synthetic data, it stuck data onto the survey. So you used to be able to call survey.deobs. That's no longer the case. So what happens here when I call simulation.make synthetic data, I give it my model. In this case, I've told it, please don't add noise to this, and let's add a noise floor. There's also a default standard deviation of 0.05, so 5%. So what this animal is that it's given me back is actually a synthetic data object. So like before, it'll still let you index this actually by source and receiver. And so it'll still give you now the datum for a given source and receiver pair. But all that it's doing when you do that is it's looking up, it's got a dictionary called index.dict right now, and we can debate about the naming, that given a source and a receiver, gives you back the indices that correspond to that datum. So this is all that it's using to look up, like if I want source number 1 and the real part of the data, then I pull out, source list at 0, and in this case, I called my receiver that's real RXRE. Oops. So it gives me back that data. The data object also has, so it always has on itself deobs, which is just a vector. So that's the vector, like what we're used to working with. That's going to be the same thing as if you do this. Oops. If I imported utils. So if you call make vec on a data object, it just gives you back the vector version of that. The other things that the data object has are a standard deviation and a noise floor. In this case, I haven't set a noise floor. And then it also has uncertainty. And so the uncertainty is just computed by multiplying the standard deviation by the absolute value of deobs and adding a noise floor. You can set any of these things. So let's say I wanted to set my standard deviation actually is 0.1. Then it still is, it's using properties under the hood. So it's smart enough to realize that, oh yeah, when you actually are saying that, what you actually mean is this. So assign 0.1 to all my data. You could equally pass this a vector if you wanted to use a different standard deviation for each datum. So if, for example, I wanted to change the standard deviation by frequency, you could do that and provide a vector of the correct length here. And what's nice is if you wanted to do that with that index dictionary, you can find the correct indices based on your sources to help do that. Does that make sense? Do people have questions about the data object?
Yeah, is it smart enough? Like, let's say I have my own way to generate uncertainty. So I generated my uncertainty as a vector.
Yeah.
I passed it into, let's say, your make synthetic data or to a data object. And then is it going to fix that, or I wasn't sure, because it seems like what would happen, let's say you set the standard deviation from 0.1 to 0.2, then you would reevaluate the uncertainty, right?
Yeah, so what happens is let me show you the code actually. So here, if we look at the data object, let's just look at the data. So the only difference between the data object and then the synthetic data is that the synthetic data object will keep track of your clean data. Just so that if you wanted to add noise, but then sort of double check, sanity check what's going on, you have both of them. But a normal data object just has deobs. So yes, we have standard deviation, noise floor, and a survey are the core things. So the basic things, sorry, that you need to create a valid data object are a survey and deobs. From there, you then have the option to add standard deviation and noise floor. And those will be necessary, or we need a way to calculate uncertainties if you want to use it in the data misfit. What you can do is you can set the standard deviation directly. And so what that would do is it clears the, you can set the uncertainty directly. It clears the standard deviation and sets your value as the noise floor. If you then went in and re-added a standard deviation, now that would be a bit funky because you would have the uncertainty that you set as a noise floor, and then you would have added back a new standard deviation. So when we go in and calculate the uncertainty, all it's doing is saying, okay, let's set my uncertainties to 0. If I have a standard deviation, then what I'm going to do is add the standard deviation times the absolute value of the observed data. And then if I have a noise floor, I'm just going to add that to my uncertainty values. Does that answer your question?
Yeah. So that looks great. Yeah, nice job.
I might have missed something, Lindsey. So sorry if you already said that. Let's say I have a UBC data file like gravity or whatever that I want to load. You said that survey doesn't have data anymore, but if I want to load, I'm gonna load a survey, but I'm unlikely to have a simulation at this level if I just want to load a data file. So how you do that? Do you create a data object along with the survey, or yeah?
Correct. So actually, what I would do is pass back, and this is currently what the DC utils, the way I've set it up, or the way I've migrated it, because previously you handed back only a survey. In this case, we now only hand back data, because data knows about the survey and it knows about the value of the data, as well as any uncertainties. So in this case, if you were to read a UBC data file that has all the survey information into it, the simplest thing to create is a data object.
Okay, yeah, makes sense.
Yeah, and I think...
Excuse me, Lindsey. So
yeah.
just suppose that you've assigned standard deviations, or you've assigned uncertainties to your data, and then, yeah, as often the case, you go ahead, you do the inversion, and then you might want to change, what you had assigned for uncertainties. Where is that done in here, or is that just done on some separate module outside?
So that's done on the data. So if I flip back to here, so this deobs thing that I created when I made synthetic data, this is a data object. And so if I went through and ran my inversion and I said, the standard deviation of 0.1, that's way too big, I should be using 0.05. Then you would do that here. Sorry, I'm just gonna. You would set that on the data. And then rerun your inversion.
And if you just had, select data that you wanted to mess around with, would that be easily done, or is that a bit difficult?
Yeah, so let's see that let's just say my first one, if we're in time domain, is a really early time channel, and I say I don't want to trust that all that much. You can do this. So you see that changed the standard deviation of my first entry.
Okay, good.
Okay. Cool. Okay, so then this example, we created some synthetic data and we can look at them. We've got some real, some imaginary as a function of frequency. And so this is what I was saying before, is that you can still index the data by source and receiver. And all that's doing, let me show you, is in the get item, it's just saying, okay, look at my index dictionary. Key 0 is the source and key 1 is the receiver. And so the index dictionary, all it's doing is it's looped through your survey and it said, okay, for each source, here's the receivers that it has, and here are then the indices that map to that data. Does that make sense?
Yep.
Okay. So that's helpful, Doug, if, for example, you wanted to find all your sources that have a frequency, or find all your data with a frequency of 1 Hertz and set the uncertainties to something specific.
Perfect.
Cool. Okay. So now we have data. So now let's set up the inversion. So the data misfit has changed a bit. So before we used to give the data misfit a survey.
Lindsey,
Yeah.
is it so like a kind of depends, but so like a sorting with the source and receiver is kind of helpful, but sometimes like actually just like having one big indices, you know what I mean? Like let's say I got 1,000 data for DC data, it's numbering to 0 to 1,000, and I have some functionality that I can pass the indices. Okay, from this indices, set the standard deviation of 3%, or set those indices to, because like yeah, sometimes like you got lots of data, then like even just having a source and receiver as a classification is not enough.
For
So
sure.
yeah, it'll be nice to have some flexibility, kind of like rather than having kind of receiver and source indices, but just having a big indices, and then.
Yeah, so the standard deviation, so here, the DOBS, it lets you treat it like a smart dictionary, but at the end of the day, it still also, this is just a NumPy array. The vector of data that it's storing is just a NumPy array. The vector of standard deviations that it's storing is just a NumPy array.
Oh, I see.
So if you wanted to go in and index into this, say I want index 0, 1, and 4 different, to be different standard deviations, you can do that. So,
Okay.
yeah, so those things are just NumPy. There's nothing fancy going on there.
Okay, good.
Yeah, okay. So now coming to the data misfit. So this has changed, is the data misfit now takes data, and this needs to be a data object, and it takes a simulation, because it needs to know how to compute predicted data. So those are the two things that it takes. Previously, it used to take a survey, and that survey had to be paired.
Lindsey, before you move on,
Yeah.
I took a look, and there's like 2 ways actually you can generate synthetic data, because you could just do a problem.dpred, or you can just do a problem.make synthetic data, and then one gives you a data class, but actually problem.dpred gives you a vector.
Yeah.
I was a little bit kind of confused about why, like why did you do that? And can you explain a little bit why is that?
Sure, because in the inversion, we always just want to be working with a vector. And so in this case here, so just to clarify, to make sure people are clear with what Seogi just said here, I've created 2 different things, DOBS and DOBS2. So DOBS is what we showed before, it's synthetic data. DOBS2 is just a vector. So it is just those data. So I can immediately start using that in the inversion. And that's the main reason for that, Seogi, is just that like this is just a simple method. All it knows how to do is compute a vector of predicted data. That's it, that's all, nothing more. Whereas if you actually call make synthetic data, what I'm saying is I actually want a data object that knows about its own uncertainties. When we're in an inversion, the dpred has no uncertainties associated with it. So it doesn't need the extra infrastructure of a data object. Does that make sense?
Yes.
Cool. Does anybody else have questions on that, or is that clear?
Yeah, that's good. So just go back to your misfit function. Are you gonna have to do a check, right, to make sure the surveys agrees that DOBS has the same survey as simulation?
That is a good point. I don't think that currently. Yeah, that's a good point. There is no sanity check under the hood that currently makes sure that those are the same thing. But I agree, that's something we need to do. Yeah, okay, so then the data misfit behaves very similar as before. And so it's going to first look to see if you have set uncertainties on your data, and that's how it'll compute the WD matrix. Same as before, though, if you want to supply your own WD matrix, you can do that. You can set your own. So here, if we go in and actually look at the data misfit, so the L2 data misfit, base data misfit, sorry. So here, if you provide a W, it'll let you set that. But if it's not there, then it's going to look at the data object and see, can I compute uncertainties? If I can, I will construct an uncertainty from there. But if they're all 0 or something like that, it's going to throw errors and say you can't set uncertainties of 0. Cool. Then the regularization has not changed at all. It's the same. Setting up the optimization inverse problem, none of that has changed. And then we can go ahead and run an inversion. So that's the gist of the main things that have changed. I've been trying to track on the this work in progress pull request the main items that are changing. I'm not really expecting, like what I'll do is I'll call people out specifically if I have questions on code that's changed, and I'll perhaps ask that people jump in and take a look at specific things, because you can see there are a fair number of changes, but this should hopefully summarize most of the main things that are going on.
Lindsey, so one of the big advantage was kind of we can serialize simulation class. Kind of, is that kind of possible now? Like how that's gonna work out?
Oh, she's proud. Oh, she's so proud.
It totally it serializes now. So there's one thing that is currently missing is that the solver doesn't serialize because it's a class right now, and so we need to write a custom serializer for that. But other than that, it's serializing everything. So you should be able to, and this is some functionality that we still need to add, but you should be able to now save a simulation and then reload it, which is really nice. Awesome. And then there should be, one of the things I would like to do is work on how to do that cleverly for the fields, because the fields object is bigger. And I think that we actually want to be looking at storing the fields arrays as something like ZAR, which interoperates with Xarray. And what's nice about that is it's meant to store large data sets, and you're able to basically index into it without loading the entire thing into memory.
Yeah, that sounds great.
So yeah, so in that way you can start to like slice through stuff, or just grab specific time indices without loading the entire animal up into memory. So that's something on the radar. I don't think that'll be done specifically for this simulation refactor, but it'll be a small, easy pull request basically immediately afterwards.
Yeah, and if we do this, we can start thinking when we create J, for instance, for the DC problems, right? We could store J to disk as well.
Yeah.
Do the same thing we did for potential fields.
Yeah. Are you storing it, Dom, as ZAR, or how are you storing it?
Yeah, ZAR, yeah.
Okay, excellent. Cool. Yeah, and so like one of the things that I really am pleased about with this is that the data, and because Gutney was always harping on this, is the data is like the entry point to actually working with SimPEG, and so I feel like we're now actually honoring that a bit more, in that like the things that you're loading, for example, when you read in a UBC file, is we're actually creating now a data object in SimPEG. And that's a very sensible thing to be starting from. Yeah, so I think that's kind of nice.
Yeah, that's great. That's great. So
That looks great, Lindsay. That really looks like a huge improvement.
got a quick question. So we have a couple of IO kind of like, then where does it leave? Like, is it kind of leaves it outside, like as it is now? Or is that do we need to put that into the data class as a method? Or what's our thought here?
So I think I'm going to stop sharing my screen because I don't have anything more to show there right now. But I think, Seogi, that we should be looking at that I think should still live outside. Mm-hmm. And I think the thing that we want to think, both with respect to IO and with respect to the idea of like drivers and things like that, I think that those are layers that sit on top of SimPEG, because the thing is we don't want to start bogging down like very simple objects that should just stay simple. So I think like sort of similar to how we have it now, and we might be able to simplify some of the things on the IO classes and try to make them a little more uniform across other methods. But yeah, those are basically like, you should be able to call an IO method and get back like core SimPEG things. And so it should do some wrangling for you and then give you back something core SimPEG.
Okay, sounds good.
Cool.
Yeah, I would vote that we move them out. We move them all at the same place, right? So that the DC IO doesn't live under static, but lives under SimPEG IO.
Yeah. No, I think that would be good. And then the same thing, I'm noticing like utils are sort of all over the place, and that's something that like I think we can deal with once this pull request is then just like start teasing some of those things apart. But yeah, I wanted to try and tackle like one thing at a time rather than changing too many things on people all at once.
100%.
Yeah. And then what's kind of cool too is I think we can start thinking about creating like SimPEG viz and be able to pass a data object to SimPEG viz and get back plottable things and things like that. And so, yeah, we can start to sketch out what that looks like, because I know Seogi has done a bunch of work on getting pseudo sections and stuff like that ready. And I've had some really good chats with Fernando about like how to start thinking about when we actually want to really be scaling up and working with large data and potentially with different plotting APIs. Like Plotly is actually pretty slick for interactive plots, like if you want to drag things around. And so it would be nice if we could readily just like interchange which plot style we want to use. Yeah, but those are things we can work with as we iterate forward. Cool. Any other questions, thoughts, concerns? No? Cool. Well, if you want to start playing around with this branch and you're sort of in the EM side of things, I would say go for it patiently. Realize that things might break or still slightly change. But if there are things that break or are not working as expected, just ping on Slack and we'll get it sorted. And then hopefully in the next week or so, I'll have a pass DOM at some of the potential field stuff and get some of your feedback at that point too.
So Lindsay, I took a look, but so examples are not really done yet, right?
Cool.
So
yeah,
is that a good place for us to help you? Is that kind of?
That would be an awesome place to jump in and help.
Okay, good. Yeah, I'll jump into examples and start to change things.
That'd be great. The tests should be working. So I've been trying to like upgrade the tests as we refactor. So if there's something that you're like, I don't understand why this isn't working, the tests are not a bad place to check it out right now.
Right.
But just a note, if you want to go and make some changes to the examples on the branch that I've made for tutorials, we've made changes to those examples. So I would look at maybe working from that branch instead of the develop, or merging it in and branching off. Because we've done some changes to the examples in the last week.
We can also, that's something that we can sort through asynchronously too.
Yep.
So yeah, Lindsay, I have an MT example forward modeling, and I'm working on a DC and IP one. That should be okay to maybe start trying to put those over as new examples.
Yeah, for sure. If you want to give it a try, you're welcome to. If you want to, one thing that you can do is like start a pull request with the current examples, and then like you can then sort of branch off and upgrade them, whatever you feel is the easiest way forward. Yeah, totally up to you.
Okay. Yeah, I just the most of the 3D ones there are just the DC. There doesn't seem to be an IP one, so maybe to start with the DC, and then I could just add the IP.
That sounds good.
Cool.
Maybe John, maybe I could also talk to you a bit about that, because I've also been trying to make tutorials for forward modeling. I've started with just simple potential field stuff.
Oh, cool.
So I have a feeling we're doing some different stuff in kind of the same project.
Cool. Yeah, well, I got some beer ready for next week, so maybe Tuesday we can sit down and talk. I'll come over there.
Oh, are you going to send to California as well?
I wonder if they'll import it.
I can share with Lindsay.
Exactly.
I'll send a case.
It's okay. I'll drink for both of you.
Doug will take it.
So generous of you, Doug.
The least I can do.
Excellent. So that brings us almost to the hour. Thibaut, I'm sorry, I wanted to make sure we had some time. So you had a point here about setting goals for Montreal. Do you want to chat about that briefly?
I just wanted to raise the point, if we had time, that that we need to start thinking what we actually want to achieve when we all meet together in Montreal on the 17th. That's the extent of my thoughts right now, but that could be related to the simulation class, because that's going to be a massive change in SimPEG, so that might be the occasions that we all work on it and test it with different methods. I don't know. Just have a plan when we come to sit down together. That's it.
That sounds good. Do you think it would make sense to start an issue, just like have a GitHub issue, and then people can add random thoughts and ideas as they come up? Would that be a...
Yeah, that can work, yeah.
Okay. Would you mind getting that started?
No, sure.
Excellent.
Cool. Would somehow framing that conversation around just getting a number of representative examples, would that be a way to kind of add tangibility to things?
Yeah, I think that would be a great idea.
So we could start to outline like which examples you might want to concentrate on, so that it's kind of generic, and we touch as many areas as possible. At the same time, if by the time we've gone through that, then we've actually got a lot of things accomplished.
That would be great.
Doug, what do you mean example here? Like a...
Well, I guess just the same as you were talking about with respect to examples for using the different kinds of surveys, potential field, an airborne EM, an MT, just to kind of consolidate both with the forward and hopefully some with an inversion, and just to, it'll beef up the examples section, and it also would be, by the time you get through that, then you've got a lot of tick marks on various boxes that, okay, we could actually do this.
So I've actually started doing this already. I've got tutorials for gravity and mag, and started on frequency domain EM. It's like a tutorial-based set of exercises that will show you, how to make the survey, how to define different types of receivers to predict different kinds of data, how you might want to plot some stuff afterwards, and it goes through slowly, and it acts as a tutorial. It provides examples, and then it also would be a test for making sure that the programming is working. So this has been something that I've been working on for the past month or so.
Great.
Yeah, so that'll be a great starting point. And then I think to Doug's point too is like, if we can all bring examples that we have together, this will also, I think, help outline like what we need to do with respect to I/O and what we need to do with respect to having like SimPEG drivers or SimPEG Lite, something like that, that is basically a quick wrapper to inversion. So for when people want to run, you know, a vanilla L2 inversion, that it's easy for them to do. So. Cool. Yeah. So Thibaut, if you're game to start an issue and circulate that around, then people can start collecting thoughts there, and we can regroup briefly next week.
Yep.
John, is there any chance you're going to be in Montreal?
I'm poking around, trying to make it hopefully work, but not too sure yet.
Okay.
I'm just waiting to hear. We got some flight tests out right now, and we're gonna have a bunch of data to process. So hopefully I can pass that on to somebody else.
That'd be great.
I just forwarded you a paper, John.
Oh.
Brand new, fresh from the press. Mag radiometry.
Oh, thank you.
I can send you the actual PDF if you want. It's big, so.
Yeah. Oh, yeah. Ronnie Stoltz is in there. Yeah, I know him pretty well, and Meyer too. Cool. Yeah. This is actually most of the guys who created our crowdstats.
Excellent. All right. Any other points, things people want to bring up before we wrap up? No? Well, thanks everyone for sticking around a few extra minutes, and we'll see you all next week and on Slack before then.
Thanks, Lance.
Yeah.
Bye.
Hi, guys.